Now, what about geographic data that's not digital? GIS data in analog form. Historically, the best example would have been aerial photographs that were captured from airplanes taking images of the surface below. These would be on film and other forms that would require you to scan them into a computer that then could be digitized. So if you can't find the hard copies, you make it yourself. And that involves, of course, going out into the field and collecting the data. And in a GIS, a lot of the data that's collected out in the field comes from surveying techniques, or going out into the field and carrying a GPS unit that marks the exact location of whatever phenomenon you might be interested in studying. Further, you could potentially acquire remotely sensed imagery from a GIS vendor or from the public domain. And increasingly, more and more remotely sensed imagery is becoming available with satellite, drone, and aerial imagery constantly being produced as we're getting creeped on from above. This might involve a lot of georeferencing. And so what we'll do in exercise 2 is we'll take a paper map from the 1800s and we'll georeference the map, which is a scanned image, and match it to a digital map's coordinate system. And we'll be using ground control points to do that as we connect one point on a paper map to that same point on a digital map. Even further, geocoding, which is a pretty broad category of operations that essentially take non-spatial info, i.e. from a spreadsheet, and convert it to locations we can actually see on the map. For example, hospital records, which say we have records of cancer patients. That's often going to be stored in a big database, and so we'll have the addresses for each of those individuals. Let's say we want to put those individual addresses and we want to show these locations on a map. Perhaps there's a cluster of cancer cases in a particular area. And that process of converting that tabular data to dots or locations on a map is geocoding. Digitizing involves actually creating polygons, lines, point, and other features onto an underlying base map. And we'll do that in exercise 2.